Next one is optimal merge pattern. Okay, highly useful problem. This is basically used in case of file compressions. This is used in case of file merging, when we are actually merging a few files together during compression, है ना, जब हम बहुत सारी files को merge करके अपनी rar file बनाते हैं या zip file बनाते हैं, उस case में ठीक है coding and encoding में इसको use करा जाता है. This particular optimization problem is used in, it has got several use cases, right? So what exactly is the problem? The problem is very simple. The problem is we have got few files. Okay, we have got few files. Okay, it may be text files, it may be database, it may be any kind of files. And then these files have got few records. Okay, and what we have to do is we have to merge all these files together. Okay, and what exactly we want the minimum possible record movement. Okay, this is the optimization problem that we are looking for, that we want to minimize the record movement. Okay, so how are we calculating the record movement? For example, A is 60. Suppose A contains 60 records and B contains 40 records, right? So what exactly we are saying that in this case, when we are merging these two files, there are 100 records movement, 60 from A and 40 from B. They are being merged into a single file. So all records are moved into a new file, right? So what we are doing is, suppose we have got n number of files. These n number of files have got different records, M1, M2 and so on. So we are going to merge them in such a way so that there is minimum amount of record movement. So let me tell you how exactly what we are looking for, what kind of options we have. Okay. So बच्चे, suppose I have three files. One file is A having record 10, second one is 20, and the third one is 30. You yourself will give me the solution, that how do you think that these should be done. So there are three different ways that we can merge these files. The first one is that, okay, I'll take A first. There are 10 records. I'll take B then, okay, and then I'll merge them into a single file. It will contain 30 records, right? 10 from A and 20 from B. And then I will take 30 records from C, and then again I'm going to merge them into a single file which will contain 60 records, right? So if I'm going to talk about external path length, how many records have been moved, then the path length for this is, this particular 10 records have to be moved twice, एक बारी यहाँ पे, एक बारी यहाँ पे, correct? So that is why its path length is 1 and 1, that is 2. Right? So the path length for B is again 2. One time here it has been moved and one time here it has been moved. All these records, right? So the path length here is 2. And what is the path length for here? It has to be moved only once, right? So if we talk about my external path length, weighted path length, so what it will be? It will be, for 10, we have to move 2 times. For B records 20, we have to again move 2 times. There are 2 branches. And for C, 30 records, we have to move 3 times, right? So the path length here is 20 plus 40 plus 30, that is 90. Correct? Now there is another way also. This is not necessarily the only way, right? The another way is that, okay, I am going to merge A and C first. Okay, so I'll take 10, I'll take 30, I am going to merge them. So there will be the movement of 40 records here. And then I'm going to take B, that is 20. Again, they will be merged together and there will be 60. Now, what is going to be the external path length over here? So here it is 2. We have to move these records twice, right? One time here and one time here. Here also we have the external path length 1 and 2, that is 2 times. And here we have only 1 time, right? So the external path length here would be 10 into 2 plus 30 into 2 plus 20 into 1, right? So it will be 20 plus 60 plus 20, that is 100, right? So in this case, we have to move 100 records. So obviously this one is more optimal than this, right? So can you think of any other way? Is there any other way of merging these files? Yes, we can merge B, we can merge C, and then there will be from 20 and 30, it will be 50. And then we have A. A is 10, again it is going to be 60. So what is going to be the external path length here? For 20, it will be 20 into 2. For 30, it will be 30. For C, it will be 30 into 2. And for 10, it should be 10 into 1. So again, this is going to be 40 plus 60 plus 10, that is 110. Again, this is not optimal. So the idea here is, bacha, the idea here is very simple. What is the idea here? If the file contains minimum records, if the file contains lesser record, it can be moved down to the tree, so that even if the path length is more, then there is no problem because the number of records in this file is very less. And if the file contains larger number of record, it should be kept closer to the root node, so the path length is lesser. So can you associate this problem with something that you have already studied?
Yes, ma'am. Yes, ma'am.
What was that? What was in Huffman encoding? What we were doing, if a character is appearing for lesser number of times, if it is appearing only for 5 times or only for 4 times, give it a bigger code, right? And if a character is quite frequent, right, if suppose this is lesser times, if a character is quite frequent character, it is appearing a lot of times, then you give it a smaller code, right? This is what we were doing there. So similar kind of thing is happening over here. If a file is having more records, just keep it closer to the root node so that the lesser movement is there, right? And if a file is having lesser record, you can keep it far away. So in this case, the path length is obviously more, but the record movements will be still lesser, because in this case the record movement is 10 times here, 10 times here, that is 20. But in this case, it is only one path length is there, but still the movement is 30. Correct? Are you understanding what I'm trying to say? The logic, are you getting, beta?
Yes, ma'am.
Yes, ma'am.
Okay, beta. So we will be doing a very simple example, and we'll be doing only one example today. We won't be taking much time because I assume that you have already done these Huffman coding numericals in your tute and you might be knowing this. So it is going to follow the same strategy, the same way we have done it in Huffman encoding. Okay. Okay, let me write the problem first. Suppose we have, the only difference, if somebody asks you that what is the difference between Huffman coding and the optimal file pattern is, beta, that in this case we are not supposed to decode, right? In Huffman encoding we were supposed to decode, right? So what we were doing is we were following certain assumptions, so that is why we were saying that the lesser value will always be the left branch and the higher value will always be the right branch, but in this case it is not required because you are simply moving the records to a new file, right? So it doesn't matter that whether the left is lesser or whether the right is lesser. That is the only difference here. Otherwise, the complete problem is same. Now you have to help me to solve this problem. ठीक है? Okay. So what was the first step there? What should be the first step in our case? What should we do? What should we do here?
Ma'am, sort.
मैम मिनिमम मिले
करेक्ट बेटा, ये जो बच्चा बोल रहा था क्रिएट मिन हीप. व्हाई नॉट वी आर सॉर्टिंग हियर बेटू? व्हाट वाज द रीजन? डू यू रिमेंबर दैट? आई हैव गिवन यू अ लॉजिक.
यस मैम, जब ऐड करके फिर से इंसर्ट करेंगे तो उसमें टाइम बहुत ज्यादा लगेगा फिर से सॉर्ट करने में.
हाँ,
वो
n
अंदर
into
n
n
पर
हो जाएगा, n स्क्वायर हो
ma'am.
जाएगा, है ना. इस केस में हमारा n log n रहता है. ठीक है, सबसे पहले हमने अपनी मिन हीप क्रिएट कर ली. अब उसके बाद अब हमें क्या करना होता था? फॉर ऑल द फाइल्स इन द हीप हमें क्या करना है? बोलो, व्हाट इज गोइंग टू बी माय फर्स्ट स्टेप? आई विल क्रिएट अ नोड, है ना. मैं एक नोड क्रिएट कर लूंगी, या फिर आप नोड बाद में क्रिएट करनी है तो आप सबसे पहले क्या करोगे? एक्सट्रैक्ट min 1, एक्सट्रैक्ट min 2. करेक्ट? यही करा था वहां पे भी हमने, राइट? बोलो.
यस मैम
So what is going to be our solution? In this case, what are we going to extract over here? Which is the
Ma'am, 10 and 15.
number of records.
B and D. 10 and 15. And then what we are doing over here is we create a new node. Create a new node. इस node में क्या आएगा? What is going to be there in this new node?
$25.
45.
In this new, the left would be this and the right would be this, right? And then afterwards, what are we going to do? We are going to
Add both
We are
of
going to-
these.
correct, beta. We are going to add the records from both the node, right? We have added the records from both the nodes, that is 25. Now, somebody please tell me what is going to be the next step. Step. I have extracted this. Extracted this means I have removed this. I have extracted this. I have removed this. Now, what should I do in this case now?
And put the sum back into the heap.
Correct. Put the sum back in the heap. उसके बाद कुछ और करना है या हम नेक्स्ट नोड पे जाएं? We'll go to here, है ना?
Next.
करेक्ट ना? इसके बाद और कुछ तो नहीं हमने करा था. तो what is there now in our heap? We have 40, 25, 20 and 25 and 30. Now what should I do now? Now we have to extract min 2, है ना? अब बताओ min कौन सा है हमारे पास?
20 and 25.
20 and 25. ठीक है, 20 तो ये पड़ा हुआ है. ठीक है, 25 आप इन दोनों में से कोई भी ले सकते हो. तो इसमें बड़ी इंपॉर्टेंट बात है बेटा, जरूरी नहीं है कि आपकी सिर्फ इसी ट्री की ब्रांचेस बनती जाएं. हो सकता है आपका एक नया ट्री बनना शुरू हो जाए और फिर वो आगे से आप कंबाइन कर लो, है ना? समझ रहे हो मैं जो कह रही हूँ? ओके,
Yes, ma'am.
वेरी गुड.
Yes, ma'am.
Very good, beta. The one thing that I have extracted is this 25 and second one is 20. ठीक है. So there is no need that I need to make 20 over here. I can keep 20 at the right also, है ना, क्योंकि इस केस में बच्चा we are not supposed to do decoding. ठीक है. So we have taken 20. 20 belongs to C. And the next step is create a new node and then add them, and we have done this. So we have taken this 20, we have taken this 25, and we have added this 45 in the heap. Now what is going to be my next step? What are the two minimum here?
25 and 30.
What should I do now? Now this 25 is not this one, right?
25 and 30.
Yes, ma'am, it's another.
This 25 is not this one. This 25 is one which belongs to E node. So in this case, I will be creating, sorry, I have to write like this. Yes, I'll create 25 here. I'll create 30 here. This 25 is of E file. This 30 is of F file. I will merge them, and this is 55. I'll extract that. I will insert in the heap. Now in my heap we have 40, 45 and 55. Now what should be done in this case?
Ma'am, we will take 40 and 45.
We will take 40 and 45, है ना. 40 आप इधर भी ले सकते हो, इधर भी ले सकते हो, वो मैं बारी बारी बोल रही हूँ. That is not an issue. So now what we are having is 40 plus 45. एक second. बस रब ना हो जाए, भगवान इतनी कृपा कर दे. ठीक है. सो दिस इज व्हाट वी आर हैविंग बेटा. 40, 45 एंड 55, है ना. दिस वाज लेफ्ट.
Excuse me, ma'am.
यस बेटा.
मैम, तो इन हफमैन कोडिंग ऑल्सो ऐसे मैम अलग अलग ट्रीज बन सकते हैं?
उसमें बेटा हमारा ये प्रोसीजर है ना कि हमारे लेफ्ट पे ही रहते हैं, तो बहुत कम चांस है कि उसमें बनेंगे.
ओके मैम.
ठीक है. सो व्हाट वी आर हैविंग इज 40 and 45. So we are going to combine them and it will be 85. ठीक है. Now in my heap I have 85 and 55. So I'll extract both of them and then I'm going to merge them. This will be 140, है ना. 140 हुआ ना.
Yes, ma'am.
Correct. है ना. So again, now in this case, what we have to find is our external path length. Correct. So external path length would be the number of branches. जैसे for A it is 2. For C it is 1, 2 and 3. Correct. For B it is 1, 2, 3 and
4.
For D?
4.
For E it is 1 and
2.
For F it is
2.
correct. So the total external path length would be 40 into 2, that is 80, 20 into 3, that is 60, 10 into 4, that is 40, 15 into 4, that is 60, 25 into 2, that is 50, and 30 into 2, that is going to be 60, right? So this is going to be my external path length, right? And tell me now, what is going to be the time complexity of this algorithm? Tell me. For creating min heap, what is going to be the time complexity for n nodes?
Log n.
For creating min heap, n. ठीक है. For if we have for all the files that we have to do, so this is my loop for I is equal to 1 to n. Okay, when I have to extract the minimum element, so the time complexity is
Constant.
log n. For this,
Log n.
for creating a new node, For creating a new node?
Constant.
Constant.
Constant. For adding the two records?
Constant.
Constant.
Putting the sum into the node?
Login.
Constant.
Login.
कांस्टेंट बेटा नोड में हमने डालना है ना हम अच्छा पुटिंग द सम बैक इनटू द हीप ये इंसर्ट हीप है सॉरी यहाँ पे एक ये था पुटिंग द सम इनटू द नोड वो था हमारा कांस्टेंट राइट पुटिंग द सम इनटू द नोड उसका कांस्टेंट बोला पुटिंग द इंसर्ट हो गया ये insert into the heap वो हो गया आपका log n right so this is going to be 3 log n plus constant so 3 log n multiplied by n right so it will be how much
And login.
the total would be ऊपर हमारे पास o n बचा है नीचे हमारे पास o n log n बचा है right this is o n plus o n log n right so what is going to be the time complexity
N login.
and what was the time complexity of Huffman encoding if you remember do you remember
Yes, ma'am. And log.
क्या कोई फर्क तो है ही नहीं है ना हम क्यों ऐसे फालतू में दोबारा से करें बट अदरवाइज ये वैसे ताकि रिवीजन हो जाए इसलिए मैंने कराया है क्योंकि जब हमने सेम प्रोसीजर फॉलो करें तो बेटा ऑब्वियसली द टाइम complexity would be similar is this okay now is this clear
Yes, ma'am.
so let us do one more example and then we will move to graph okay beta ओके बेटा सॉल्व करिए छोटी सी प्रॉब्लम ही दे रही हूँ ज्यादा बड़ी नहीं है सो दैट आपकी प्रैक्टिस हो जाए एक बार ही देख लेते हैं उसमें कोई प्रॉब्लम ना आ रही है So find the optimal merge pattern for this data. This is 12, 32, 5, 84, 53, 91, 35, 3 and 11. Okay. ये 53 इकट्ठा है, ठीक है, G, H, I and J. Okay, so we have these files and these are the records in those files. ठीक है, we have 28, we have 12, 32, 5, 84, 53, 91, 35, 3 and 11. हो गया? हाँ, पहले तो बेटा मुझे ट्री ही बता दो, क्या है हमारे रूट पे। दीपांशु आपका हो गया ना बेटा? मैं एक बार ट्री बना देती हूँ ताकि बाकी, हाँ बताओ।
ऊपर से बताएंगे, ये 5 सबसे पहले लिए थे,
तो नीचे से बताओ, से बता, या ऊपर से ही बता दो, बोलो।
नीचे से
चलो ठीक है बच्चे। सो सबसे पहले हमने डी लिया और सबसे पहले हमने आई लिया, है ना? यही कहना चाह रहे हो ना दीपांशु?
यस मैम।
फिर उसके बाद बेटा बताओ।
मैम 8 आ गया, 8 के बाद 11 जे, मैम जे लेंगे 11 और दोनों को मिला देंगे।
फिर
12 बी।
फिर बेटे 31 आ गया। 31 के बाद मिनिमम कौन सा है? 28
ये
28 और 31 हो गया 59, है ना?
यस मैम।
फिर उसके बाद 32 और 35,
यस मैम,
है ना? 32 और 35 हुआ ना?
यस मैम, तो अलग बन जाएगा इसका।
ठीक है बच्चे, ये हो गया 32, ये हो 35, ठीक है। ये मेरा आ गया है 67, करेक्ट?
यस मैम।
ठीक है, फिर उसके बाद बोलो दीपांशु।
ये दोनों मिल जाएगा क्योंकि नो, यस मैम, क्योंकि 84 है इससे के बाद।
नो मैम 53 भी तो है। 59 और 53।
ओके, सो वी हैव 28 हमारा कट चुका है, 12 हमारा कट चुका है, 32 हमारा जा चुका है, 5 हमारा जा चुका है, 84 अभी हमारे पास पड़ा है, 53 हमारे पास पड़ा है, 91 है, 35 हमारा कट गया है, 3 हमारा कट गया, 11 कट के साथ हमारे पास पड़ा है 59 और 67। तो अब इसमें मिनिमम कौन सा है?
53।
59 और 50, ठीक है ना, तो हम यहाँ पे ले लेते हैं हमारा 53 जो कि F है, करेक्ट बेटू, ये बन जाएगा मेरा 112। ठीक है, इसके बाद अब बताओ, इसके बाद अब हमारे पास क्या बचा है, 84 बचा है, 91 बचा है, 67 बचा है एंड 112 बचा है. So now what we are going to do over here is
67 and 84.
67 और 84.
correct. बिल्कुल सही, 67 and 84. Perfect. So this is going to be what? This
वॉइस कट रही है,
यस मैम, वॉइस कट रही है.
बिल्कुल ही कटी.
and
मैम वॉइस नहीं आ रही है आपकी.
यस मैम.
मैम आपकी आवाज बिल्कुल भी नहीं आ रही है.
बेटा अभी ठीक है? हेलो
यस मैम.
हेलो, मुझे आवाज आ रही है मेरी?
कट रही है थोड़ी सी.
कट रही है.
यस मैम.
दीपांशु आवाज आ रही है बच्चा?
हम ब्रेक होती
यस
है
मैम,
अभी
कट
थोड़ी थोड़ी.
रही है, ब्रेक हो
मानव,
रही है.
बस फिर आप
थोड़ी सी
छोटा
ब्रेक
बता दो, आपका आंसर निकल आया है ना?
यस.
Yes, ma'am.
मानव आंसर निकल आया, क्या आंसर है?
मैंने सॉल्व नहीं
रूट
किया.
नोट पे क्या है आपका?
मैम 354.
हाँ, तो बस फिर उसके बाद मैं अटेंडेंस ले रही हूँ. हेलो
यस मैम.
हेलो, हाँ
Yes.
बच्चे मैं ना बस अब अटेंडेंस ले रही हूँ. ठीक है, 2 मिनट के लिए आप लोग लीव मत करना. एक बार अटेंडेंस लिस्ट में डाउनलोड कर रही हूँ। हाँ बेटा 354 बिल्कुल ठीक है। अगर आपको मेरी स्क्रीन दिख रही है तो मेरी स्क्रीन में भी सेम वही है, ठीक है। सो इन दोनों को हमने कंबाइन करना है, 203 और 151 को। सो दिस विल बी 354. ओके फाइन, होप दिस इज क्लियर टू ऑल ऑफ अस। यस
Yes, ma'am.
ओके बेटा, गुड, थैंक यू। ठीक है बच्चे, ओके, आई विल टेक योर लीव एंड देन वी आर गोइंग टू कंटिन्यू दिस टॉपिक इन योर मंडे लेक्चर, है ना। मंडे लेक्चर में हम और बाकी की एग्जांपल्स करेंगे। तो ट्यूट में मेरे बेटे हम लोग क्या करेंगे इस बारी? पिछली बारी ट्यूट में हमने करा था नैपसैक एंड हफमैन कोडिंग। इस बारी हम करेंगे मैंने क्या क्या प्रॉब्लम कराई है, एक तो आपको कराई है जॉब सीक्वेंसिंग विद डेडलाइंस वाली, और एक हमने करनी है ऑप्टिमल मर्ज पैटर्न। ठीक है बेटा?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay.
Yes, ma'am.
Great. Great. ठीक है, the same two topic will be covered in your lab also. All right, beta. Bye. Have a great weekend.
Ma'am,
Thank you, ma'am.
Yes, Manav.
हमें एक क्वेश्चन था। हम जॉब सीक्वेंसिंग की वेरिएशन है, मतलब हमें सिर्फ डेडलाइन दी हुई है ना जॉब वेरिएशन, उसमें जॉब सीक्वेंसिंग प्रॉब्लम में।
हाँ।
हम अगर हमें स्टार्टिंग एंड एंडिंग पॉइंट दोनों दिए जाएं और हमें तब मतलब प्रॉफिट नहीं है कुछ
आपको याद हो तो ऑपरेटिंग सिस्टम में भी हम ये